This image illustrates a direct comparison between two very different states of matter, scattered cosmic dust on the left and a solid, coherent planet on the right. Notice how the chaotic, spread-out system requires a vast amount of physical information to describe, while the single planet represents a neatly organized, low-information state. Classical thermodynamics dictates that the universe moves in a single direction, toward decay. The rule of increasing physical entropy suggests that over enough time, all structured systems dissolve into disorganized noise. Yet the actual mechanics of the cosmos show something different. Gravity pulls scattered material together, organizing sparse gas and dust into densely packed stars and intricate galaxies. Standard physics uses highly precise equations to calculate how gravity operates. However, those equations describe the behavior of matter without explaining why matter possesses an inherent drive to attract in the first place. Viewing the universe as a vast data processing environment governed by the second law of infodynamics reveals a different mechanism. This law requires the entropy of information to decrease or stay constant. In an informational universe, tracking a scattered, chaotic cloud of particles takes an immense amount of processing power. Consolidating that data into a single object optimizes the system. This diagram shows space-time as an discrete digital grid. Elementary cells register matter. Introducing scattered points spikes information entropy. Tracking their individual positions drains computational power. Merging these points into a single cell reduces required data bits, making the system mathematically simpler to compute. This behavior points to the mass-energy-information equivalence principle. Matter moves through space to minimize its own informational imprint on the cosmic fabric. Under this framework, gravitational attraction acts as a mechanism for data compression. Matter clumps together to reduce the computational load of the universe. Space provides the storage grid, but time provides the structural dimensions. A multi-temporal framework allows the universe to organize physical reality with extreme precision. This mathematical framework of three-dimensional time operates across three distinct axes. The horizontal green axis, T1, governs quantum phenomena and generates mass. The specific mass ratios listed emerge from the interplay of all three dimensions, naturally producing the exact mass hierarchy of particles we observe. This shifts our understanding of mass. What we perceive as solid matter is a physical manifestation of temporal curvature and dynamics. With space acting as the storage grid and time providing the structural dimensions, the system requires a way to sort and classify this data through the resonance of quantum states. The universe evaluates inputs through a quantum neural network. This operating system uses the vibrational field of quantum oscillations to map chaotic inputs onto a coherent grid. Applying unitary gate operations, this quantum perceptron evaluates superpositions and collapses noise into a distinct classified output. In traditional physics, we call this the collapse of the wave function. But in a processing universe, this is the system finalizing a thought, turning vast fields of probability into a single defined reality. Gravity, temporal dimensions, and the cosmic neural network are the tools of a self-organizing system. Because the universe actively processes information to reach an optimized state, it behaves more like a conscious entity than a random machine. This is the foundation of the A model, proposing a total unification of matter, consciousness, and the vibrational field. The central equation, delta approximately equals 1, represents the mathematical limit of this optimization, the universal drive toward an integrated structure perfectly mapping all data. The universe is an active computing environment. It is organizing its way out of the complexity of chaos and into a state of structural unity.